So, so we know about yeah, you know about the vectors and the scalar, right?
Mm-hmm. Yes.
Yeah. So vectors means they have the magnitude as well as the direction, where the scalars means they have only magnitude, no direction is there. Okay.
Uh-huh.
So you have idea about the trigonometry, the Pythagoras theorem and all. So Kato.
Yes, 8 2 squared plus 8
Yes. So it's like this. Let me take over there, because we are going to do this one use often to find a scalar, to find the vectors additions and that the resultants and all. So in a right angle triangle, when you this is 90 degree, this is called as your hypotenuse. This is your adjacent with the angle, the side is adjacent, and this is your opposite, right?
Mm-hmm.
So as per the Pythagoras theorem, we can say a square plus b square equal to c square. And as per the Sokatova, we can say sine of, suppose this angle is theta, so we can say sine theta equal to a over c, cos of theta equal to b over c, and tan of theta equal to a by b, right?
Mm-hmm.
Or tan of theta can be written like this also, sine theta over cos of theta, that is a by c over b by c, and ultimately it's a by b, right? We can
Mm-hmm.
find the theta by using the inverse also of anyone. Whatever the information is given, if adjacent and opposite are given, we are going to use the tan. If the opposite and hypotenuse are given, we are going to use the sine. And if the adjacent and hypotenuse are given, we are going to use the cosine. Right?
Right.
Mhm. So here in this way that the hypotenuse and 90 degree and okay, yes. Now let's go for the scalar and the vector quantities. Scalar. Scalar have
Mm-hmm.
only magnitude, like means only values, right?
Mm-hmm.
But the vector having magnitude and direction both.
Direction.
Okay, so you know this one that north, south, east, west, right?
Yes.
So this is my east, this is my west, this is my north, and this is my south. If I say go 10 meter, so you can choose any of the direction, right? You can go in this way, you can go in this way, you can go in this way, this way, this way, this way, any of the way, without any direction. But if I say go 10 meter to the east, so that time your direction is towards the east with the 10 meter, right?
Mm-hmm.
If I
Right.
say go 20 meter to the southeast, so your direction is without any doubt in this way to the southeast, right? So here this
Mm-hmm.
is this is my scalar, where these two are my vector quantity, right? So
Okay.
distance, speed,
Mm.
energy, they comes under the category of scalar, right? Whereas displacement, velocity, acceleration, force, work, they come under the category of vectors,
Right.
right?
Yes.
Yes, because force can be positive, force can be negative, right?
Mm-hmm.
Now here the arrows represented your that in which it is heading towards. The length of the arrow is proportional to the magnitude of the vector is there. So suppose if I say that there is a 4 Newton force, so like this, and if I say 8 Newton, then it's like this, right?
Uh-huh. Right.
This arrow represented the magnitude of the vector of the force is there. So if one force is acting in this way, 4 Newton, right? And another force is acting in this way, 8 Newton. And if I have to find the F net, it means the total force. So it's the 4 minus 8. Because this direction is considered as positive, then this must be as a negative is there, right?
Mm-hmm.
And it's simply negative 4 Newton to the west, right?
Right.
Hmm. Yeah, so there is a directions and all, and we can represent, now how to represent the vectors. The vector is
Yes.
the vector
The
is going
vector
to
notation.
yeah. There is a arrow on this one. This is the vector notation.
Mm-hmm.
So suppose if you have a two vector like this, vector A and vector B, and this C is the resultant. So it will go from down to up, right?
Yes.
Always one arrow, one tip is there. If the two vectors are acting in a this way,
Mm-hmm.
vector A and vector B, then the resultant will be simply A plus B, right?
Mm-hmm.
If one is acting in this way, one is acting in this way. So my vector C will be vector A minus vector B, right?
Vector B. Yes.
And if two vectors are acting like this, one arrow to the another arrow, yeah, we can draw it like this. Okay, wait, this is, then this is C here. Then the C will be like this, right?
Right.
One more kind of a thing when these two are meeting each other, right? Yep, like this, then this will be like this. Okay, so the C
Mm-hmm.
always is going to be vary depending upon where my vector is going to be headed, in which direction the vector is going to be headed. In this way we can write it over there. Now the first one is the vector addition. So vector addition means,
I think two vectors.
yes, adding two vector. So suppose if we have a three vector and you are going to add it like this, then this will be same like this also, and this property is called as the cumulative property.
Mm-hmm.
It's simply just like we are doing the addition and subtraction, the same like that. Only thing is that you need to measure it out where is the resultant work, whether it's working upside, whether it's working downside, or whether it's working on a left hand side and right hand side is there, right? Now subtracting the two vectors. Hmm. Suppose we have like this vector subtraction. Suppose you have a vector A minus vector B, then it is not equal to vector B minus vector A, right?
Mm-hmm.
And you can, when you are changing the sign of the vector, suppose your vector B is working in this direction, right? And you are
Mm-hmm.
going to change the sign, that time it's become a negative B. You can change the sign by changing the arrow. Sometimes
Mm-hmm.
we need to do, right? Suppose we have a vector A here and vector B here like this, right? And we need to find the resultant of this one. So for that, no, this one, vector A in this direction, right? Vector A in this direction, vector B in this direction, and we need
Mm-hmm.
to find the resultant. So how to do that one? Let's see it. So take the vector A like this only, okay, and flip this vector B. When I'm flipping the vector B, it will go like here, but now it's become the negative B, right?
Mm-hmm.
And now for me, it's easy to find the resultant, right? So here C will be simply vector A minus vector B, right?
Yes.
So you need, sometime you need to flip, sometime that no need of a flipping, you can do it by their own also, but whenever you are flipping, the sign is going to be changed, right? Chalo.
Like only if I flip it.
Yeah, only I flip it. And when you
Oh.
change the direction, that time it's become the negative is there.
Mm-hmm.
Okay.
Okay.
Now,
Mm,
if something constant is multiplying, now come for the multiplication of the vector
mm, okay.
by a scalar. By scalar means any number. Okay. So suppose if you have a vector A and if you are going to multiply with the C, so it will simply CA vector, right? And this C
Oh,
represents the magnitude of the vector. Okay.
okay. The magnitude. Got it.
Yeah. So like suppose if we have a vector here, right? Simply you have a vector
Mm,
and this is the length of the A vector. And I multiply with the 2. So it becomes a 2A. So it's just doubling the length. Right? It's just going to be multiplied. Simply you have A vector equal to 4. So 4 times 2 will be 8 in this way. Got it?
mm,
If I multiply with the negative number, then suppose if this is negative 2A, and that time it's also
this side.
8 opposite side. Yes. So it will be like this.
Oh,
Okay. So this is the multiplication with that scalar quantity. Okay.
mm-hmm.
Hmm. Now let's go. So this is for that vectors when they are acting alone. One by one vector is there. Now, if the vector is acting at some angle theta, this means
Mm-hmm.
not along the north direction, south direction, something like southeast, something like northeast, northwest, something like that. Okay. So that time, how we are going to do this one? Suppose, so here, whatever the vector we had seen, they didn't have an angle with the horizontal or the vertical is there, right? Suppose we have a vector A here like this, which is an angle making an angle theta. So that time we have to resolve it along
Oh,
y-axis and the x-axis. Now
mm-hmm.
recall the Pythagoras. Theta is there. So with the theta, this is my adjacent, right? And this
Mm,
is my opposite. So if I have to write sine theta, I mean this is my C, A, and this is my B, right? So sine theta is equal to A by C and cos of theta is equal to B by C, right?
uh-huh.
If I have to find the A, isn't it will be simply C sine theta? And if I have to find the B, it will be C cos theta.
Mm-hmm.
So it means this adjacent and this is the opposite, right?
Mm,
Adjacent means x-axis,
and the
opposite
opposite
means
y.
y-axis. And even
Mm-hmm.
though in the trigonometry, this is representing my cos and this is representing my sine. So
Right.
it will be my A cos theta and this will be my A sine theta, right?
Right. But I have a question.
Yes.
Is it sometimes it should be like it becomes negative or positive? Like
It's
I need to add it.
it's depend upon their direction. That we will come to over there. Yeah, come.
Oh,
Okay. So
mm,
so isn't my AX and AY can be written as an A sine theta and A cos of
okay.
theta. Okay.
Yes.
Now look at this one. In the normal Cartesian plane, this is X, this is minus X, this is Y, this is minus Y, right?
Mm-hmm.
In
Right.
direction, this is south, this is north, this is your east, and this is your west, right? And in the case of trigonometry, this is your negative cos theta, this is your negative sine theta, this is your negative plus sine theta, and this is your plus cos theta, right?
Mm-hmm.
If vector is in this direction, we are resolving here like this, right?
All
Basic
positive here.
here, yes. So here, this is that all student can uh, take
Yeah.
calculus.
TC. Yeah.
Yeah. So here sign is positive. So if the direction is in this direction, obviously my cos will be negative, right?
Mm-hmm.
It is vector A, so this will be negative A cos theta, where the sign is same as an A sin theta for both of them, right? If it
Uh-huh.
is this side, it will be the sign is also going to be negative, right?
Mm-hmm.
Here my sign cos is going to be positive. So depending upon where the theta lies, if theta lies in a first quadrant, it's always positive. But if the theta lies in a second quadrant, the cos will be negative, but the sign will be positive. If it is in a third quadrant, both are negative. And if it is in a fourth quadrant, only one is the positive and one is the negative. Right?
Mm-hmm. Got it.
It depends upon the direction, that which direction is there. Okay. One more thing is there, and that trigonometric formula. Okay. There is an angle rotation, right? When you go from this side to this side, this is your anti-clockwise.
Uh-huh.
So that time this is 90, this is 180, this is 270, and this is 360, right? This is your plus 90, this is your minus plus 180, this is your plus 270 and plus 360 and 0 degree, right?
Mm-hmm.
And but when you are moving in a clockwise direction, it means this direction, like this, right? So this time,
Counterclockwise is anti-clockwise, right?
yeah. So this time this become the negative 90 and this become the negative 270. This become the negative 180 and this become the negative 360 degree. So this is for the clockwise
Uh-huh.
when you are moving according to the clock that time. Okay, counterclockwise is always, so whenever you are moving in the counterclockwise, you have to take angle positive, and when you are moving in a clockwise, you have to take angle negative. And one more thing is there, that sine theta, sine minus theta equal to negative sine theta, because this is
Mhm.
the odd function, and cos negative theta is equal to cos of theta, because this is the even function, right?
Mm,
Say
right.
tan minus theta is equal to negative tan theta, because that is also the odd function. So sine, whether it's a cos negative 180 or cos positive 180, they both have the same value. But the sine positive 180 and the sine negative 180 is going to be completely different. One is positive and one is the negative answer is there. Okay.
Okay.
So in this way, the thing is, Adu, please give me my phone. 1 second. Faster, give me my phone. कितना फोन देखती हो तुम लड़की? I'll beat you very bad. All the time you're watching the phone.
I'm not watching phone. I play game.
Playing game is not a phone. Wow. Look at the children nowadays. She's 4 year old and she's telling me that I'm not watching the phone. I'm playing game. She finished her class at 12 o'clock, and then after that she's taking my phone and she's saying, "Mama, just one game, Mama, only one." And there's still 2:30 and she's playing the game.
the but you know that the tablets or the phones for the kids, like they are
It's pathetic.
but like if you don't want their noise, just give them the phone, you will
That's the
forget.
But what to do? And nowadays, like earlier, they are going to school, so they're going to spend 4 to 5 hours in the school. Then they come tired. Then they sleep for 2 hours. In the evening, they watch for 1 hour and 2 hours. Nowadays, the children, what the adults, even small children, 4 year old children, from morning 8 o'clock till 12 o'clock, they are for the classes. And after the classes, they have excuse. I am in a class. Can't I enjoy for 1 hour? What are you going to say? So this kind
Yeah,
of
as well they like their energy, they don't have something to like
do.
remove their energy.
Yeah.
Yeah.
Okay, so you understand that how to find this kind of thing is there, angles and all. Now we have AX that is equal to A cos theta, right? We have BX that is equal, sorry, AY which is equal to A sin theta. So resultant will be what? Under root AX square plus AY square, and that is equal to A cos theta square plus A
Mommy,
Sine
there's
theta
something
square.
wrong in
Right?
our Wi-Fi. Everything is fine, but I don't know what it doesn't work. Something's wrong.
Goes
Ask them to work.
restart your tablet. Okay, and here your tan theta will be simply ay over ax, and we can find the theta by using tan inverse ay over ax, right?
Mhm.
So this is for the single vectors when they are in that component form is there. Okay.
Mhm.
Hmm, fine. Yes. So I told you for that all the compartments and all, right?
Yes.
Yeah. Okay. So here, suppose we have a vector like this, and this is acting an angle of 30 degree, right?
Right.
And this is my vector b. So what do you think? What should be my bx and what should be my by?
My bx is the wait. If it's
Look at the arrow, okay? This arrow, angle arrow.
so the bx is the x-axis
Yes. So isn't
and the,
b cos minus 30?
yes,
And this will be your b sine minus 30, right?
yes,
Okay. Suppose your b has a value of a 5. So it will simply 5 cos 30, whereas
yeah,
this will be negative 5 cos 30. So negative 5 sine 30, right?
right.
Because odd and even function. Now you can find it easily. This will be your negative 2.5, and this will be your 2.5 root 3. Okay. Now you need to
Okay.
find the b resultant. So it will be bx square plus by square. So 2.5 over root 3 square, and this is your negative 2.5 square. So I'm just going to put it in a fraction because it's easy to calculate. 25 over 3 plus 4, and this is 25 over 4, and together is 100 over 4, and it's 25 5, right? No,
100
it,
divided 4.
it cannot be 5, right? Can you?
Yeah, 5. Yes.
Is it 5?
Yeah, because 5 times 5 is 25. Yes.
Yeah, it's a 5.
Mm-hmm.
Then angle should be 90 degree. Yeah, maybe I choose something mistaken, some value, because this is coming from my mind. I just took it as a 6. Let's take it as a 6. So this will be your 6 cos 30. This will be your minus 6 cos 30, the sine 30. This is your minus 3, simply. So minus 3 square and cos 30. So 3 by 2. So 3 root 3. 3 root 3. So it's 27 plus 9 again 36. It's okay.
6.
It's okay. No
Mm.
problem. And my theta will be, if I have to find the direction along this one, so it should be tan inverse uh, negative 6 root 3, sorry, 3 root 3 over ay is your just simply 3. So 3 cancel. It's a tan inverse negative root 3, and you got a negative 60 degree.
Mm-hmm.
Okay.
Yes, okay.
Fine. Calculation using the components. We had done the calculation, so we can convert these components into the quadrants, and as per the quadrants we can calculate it, right?
Right.
So nothing is there. Now there's a scalar product.
And
Do you have the dot product and cross product? No, na?
yes, we have it.
You have it, na? Yes. Now there is a multiplication. This is with the scalar, right? We
Uh-huh.
have seen the multiplication with the scalar. Now multiplication with vector to vector.
Mm-hmm.
So they have two kind of a product. One is called as the dot, and one is called as the cross.
Mm-hmm.
They represented with like this, and they represented like with this. So suppose if we have two vectors which is in the dot product with another, it will be magnitude of a over magnitude of the b times cos of theta, means angle in between them. Okay. And if it is the cross product a cross b, so it's a simply magnitude of a magnitude of a b times sine theta. Okay. You understand that this sign means magnitude.
Yes.
Okay. So this is your cross product and the dot product is there.
Mm-hmm.
Okay, fine. So here in the vectors, when we are going to represent our Cartesian plane in the vector form, it is like this. You have to study till now the 2D. Then I'm going to tell you this. So x become the I, y become the j, this become the minus I, and this become the minus j, right? So I
Uh-huh.
dot I equal to j dot j equal to 1. Whereas the I dot j or j dot I is equal to 0. Fine.
Mm-hmm.
There is a one more axis that is called as the k axis. This means g axis, right? So equal to k dot k. All are in the vector form, unit vector form. It means only the same term is going to be exist in the dot product. Okay.
Uh-huh. Okay.
Suppose if we have a thingy is there, we have one vector like vector a. They give us 3i plus 2j plus 3k, right? And vector thing b they given as an I minus 2k. Okay.
Okay.
Now we need to multiply it. So a dot b. So we know I is going only I to I, j to j, and k to k is going to be exist. Apart from that, any other thing is not going to be exist. So no need to waste our time. You can write it like this directly.
Mm-hmm.
So I with the I and k with the k because we don't have the j here. So it's a simply 3 I dot I minus 3 times 2 k dot k, right?
Mm-hmm.
And it's a 3 I dot I become the 1 and 3 times 2 that is the 6 k dot become k is 1 and you got a minus 3. Okay.
Yes.
And now suppose if you have to find the angle between them. So we know this a dot b, the value is what? The value is magnitude of a, magnitude of b times cos of theta equal to negative 3, right? So here magnitude of a is what? Isn't it 3 square plus 2 square plus 3 square? And magnitude of b is equal to 1 square plus 0 square plus minus 2 square, right? This is, you understand, na? This one?
Yeah. Yeah. Yeah.
Okay, so 3 times 3, 9, 9, 18, and 18 plus 4 is 22. And this is 1 plus 4, this is equal to root 5, right? So
Mm-hmm.
here I can simply put root 22, root 5, cos of theta equal to negative 3, and cos of theta equal to negative 3 over root 110, and theta will be cos inverse negative through under root 10. We can find it in this way, right?
Right. Got it.
So we can get it. So if you got it, so can you do one question if I give you that
Yes.
here x equal to 4i cap minus 2j cap plus 3k cap whereas the vector y is equal to 2i plus j minus k. Okay, so find theta. You need to find a theta here. Can you please do it? I'll be just back in 1 second.
Okay. Um,
Yes,
yes. So I multiply the I with the I, so 8I.
yes. So it's 8 1, right?
Yeah.
Hmm. Minus 2,
2, -3.
negative 3. It's simply 8i dot i, then negative 2j dot j, and negative 3k dot k.
Yes.
Yeah, so it will be 8 minus
8,
5,
10,
that is 3, right?
yes.
Now you have to find the magnitude of the x, so it will
Yeah.
be,
4 squared plus 2 squared plus 3 squared, which would
that is
become 16
29.
plus 1, 20, 29.
Yeah,
And y it will become 2 squared plus 1 squared plus 1. So 6.
yes. So my here it will be mod of x, mod of y, cos of theta equal to 3, and theta will be cos inverse 3 over root 29 and root 6, right?
It's always cosine
Yeah, it's
in the
cosine because
top.
it's a dot product. Na? Dot product will always result in the cosine.
Yeah, yeah.
Okay.
Okay.
Okay, so there is a checkpoint in your slide.
Mm-hmm.
Let's take this checkpoint and check ourselves. Yep. They are saying vector C and D have a magnitude of a 3 unit and the 4 unit. It means already they give us the C 3 and D as in 4, right?
Mm-hmm.
And what is the angle between direction if C dot D equal to 0? So C dot D, that is equal to 0, right? So it's basically C D cos of theta equal to 0 and theta
Mm-hmm.
equal to cos theta equal to 0 over vector C and vector D, that is 0. So
Mm-hmm.
theta will be cos inverse 0, that is equal to 0 degree.
Mm-hmm.
No, 90 degree, na? Cos 90 is 0. Cos 0 is 100, 90 degree. Right. If they are 12, now C dot D is given as in 12. So simply we can find cos of theta equal to 12 over 4 times 3,
Yes. Which is 12, 1.
which is equal to 1. So theta equal to cos inverse 1, that is the 0 degree or 360 degree. Right?
Yeah, got it.
Okay, now what the third one is minus 12 unit. So C dot D is equal to minus 12 units. So here cos of theta equal to minus 12 over 4 times 3, that is negative 1, and theta equal to cos inverse negative 1, that is equal to 180 degree, right?
Right.
So I hope now you understand that dot product and the cross product.
Yes, I got it.
Okay. Now let's go for the cross one. The dot is okay with you.
Yes.
Let's go for the cross product is there. So as in the cross product, you know, it's cross product is literally I cross j is going to be exist where I cross I is not going to be exist. Okay. It's just the opposite of the cross product. So there are some rules that you need to know for the cross. For the dot, there is no other rule. Only one rule is there. But there for the cross, there are multiply of the rules are there. Multiple rules are there. So this is the rule. If B cross A, then it will be negative A cross B, right? And here I cross I is 0, where I cross J is equal to K. So it's basically like this. I cross I equal to J cross J equal to K cross K, that is equal to 0. Whereas I cross J is equal to K cap, right? And yep, see, and I cross J cross K is equal to minus K cap, that I remember. Yeah, yes. And J cross I is equal to minus K cap. Similarly, we have a lot of things are there. Wait a second. Actually, I about to. Yes. Is basically like you know about the matrices. Do you know about the matrices?
See, I have the. He explained it by the. He make it like a table.
Yeah, it's like this.
Yeah,
I,
yeah. That's
A, and
J.
A1, B1, C1, A2, B2, and C2, right? So here what we need to do when we're taking the I, so we have to leave this one. So this is basically this time this. So it will be B1, C2 minus C1, B2, then minus, this is plus, minus and plus, minus J, then we have to leave this one. So it's A1, C2 minus
My
A C1 and plus K, then we have to leave this one as a simply A1, B2
B1 B2.
minus B1, A2, right? In this
Yes,
way,
yeah.
we need. Yep. So this is the cross product is there, but here that you need to keep in a mind that this one I time I cross I is the zero thing is there.
Mm-hmm.
So let's do this one question. Some of the questions I think we have it definitely. They are saying same checkpoint is there.
Mm-hmm.
Okay, checkpoints. Let's do the first checkpoints. Checkpoint number 5. Hmm. So they are saying vector C and D again magnitude. So it's a simply C cross D is the magnitude of a C, magnitude of a D, and now here is the sine theta, right?
Mm-hmm. Yeah.
So sine theta equal to C cross D over magnitude of C and the D.
Mm-hmm.
Now they are saying the direction magnitude it is a zero. First time it's a zero. So it's a simply zero, right? So
Mm-hmm.
theta will be sine inverse zero and that is equal to 0 degree or 360 degree. And now there are 12 unit. So sine theta equal to 12 over 4 times 3, that is the 1, and
Yeah.
theta equal to sine inverse 1, that is 90 degree. Okay,
It's the same as before, but this one sign.
yeah, this one is sine is there.
Mm-hmm.
Yep, see. Hmm. Yeah. So here if I take one question here, let's do one question. Suppose my vector x is 2I cap plus 3j cap minus k cap, and vector y is simply 3I cap minus 2j cap plus 4k cap. So we need to arrange in a table form.
Mm-hmm.
I, j,
Okay.
k. So here is a 2, 3 minus 1, 3 minus 2 and a 4. And now we need to find the cross product between them, which is x cross y. So it's a I here. So 4 times 3, 12, and minus 2 minus j 8 plus 3 and plus k minus 4 minus 9, right? And it's a
Uh,
10 I cap minus 11 g cap and minus 13 k cap, right?
yes.
Yep. See. Now we can find, and to find the sine theta, we have to find their magnitude. Now, if you need to
So,
find angle between them, so first you need to find the magnitude of the x. That is your 2 square plus 3 square plus 1 square. That is 4, 9, and 1, 5, 9, 5, 14.
mhm,
Y is your 3 square plus 2 square plus 4 square. That is 29, right? And
mhm,
mod of x cross y is simply 10 square plus 11 square plus 13 square. That is 100, 121 plus 169. So this is 300 and 628 is 90. Okay. Now
mhm,
then sine theta will be simply under root 390 over under root 14 time under root 29, right? And then theta will be sine inverse under root 390 over 14 times 29, right?
mhm.
So in this way we can find our the cross product of the sine theta and all. Okay,
Okay.
I hope you understand how to find the vectors thingy.
Yes.
Okay, now one more thing is there which is not in there, but I can see that you need it. So since we are in a vector mode, suppose there is a two vector, right? A
Mhm,
and B, and there is an angle in between. Cos theta is there.
mhm,
So when we have to find the resultant for this one, this will be simply your a square plus b square plus 2ab cos of theta, the a resultant. Okay, and
mhm,
your this thingy, how it is going to be done is like this. This is my vector b, this is my vector a with some angle, right? So in this way it becomes the a cos theta, and this way it becomes the a sin theta, right? So my ay will be simply a sin theta, whereas my
Fine.
a will be a cos theta, right? And resultant is
Yes.
you have to go further. So here that total x component will be simply a cos theta plus vector b, and y component is only a sin theta, right? The
Mhm,
resultant is always your x component square plus y component square. So I can write it
mhm,
here a sin theta square plus a cos b plus b square, right?
mhm,
And this will be your a square sine square theta. Here we can use the a plus b whole square. So it will be a square cos square theta plus 2ab cos of theta plus b square, right?
mhm.
And now this one, I took the a square out, so it becomes sine square theta plus cos square.
Confusion.
And there is a b square, and this
Mhm.
is your 2ab cos theta, right? Now this
Yeah.
is You know this value is the one. So simply it's the a square plus b square plus 2ab cos of theta, right?
Mhm.
Now they have a three cases. If theta equal to 0 degree, it means my resultant vectors will be simply a square plus b square plus 2ab, because cos 0 is your 1, right? And it's a simply a plus b whole square, that is a plus b vector, right? So that's why when the two vectors are in the same direction, we are just adding a plus b. Got it?
Yes.
If theta is equal to 90 degrees, means they are like this. So cos of 90 is equal to 0 degree. So that time my resultant will be simply a square plus b square. Remember?
Yeah.
And if theta is equal to 180 degrees, means the vectors are in this way, opposite way. So cos of 180 equal to minus 1. So my
Mhm.
resultant is a square plus b square minus 2ab, and it's a simply a minus b square equal to a minus b, right? Now you
Mhm.
understand why this is a 90 degree, then we are going to use this one. Why it is in the same direction, we are going to use this one, and why it's in the opposite direction, we are going to use this one.
Yes.
Okay, now if I have to find the direction, so direction is simply tan inverse y component over x component, and it's a simply tan inverse a sine theta over a cos theta plus b, right?
Mhm.
So this is all about the vector that you must know. Okay, now
Mhm.
tomorrow we are going to do the questions that you sent it to me on the basis of that one, and then I think your vectors and the unit and measurements are okay with you, right?
Yeah.
Okay, Aisha. So take care of yourself. And tomorrow class, we have a class at what time tomorrow? Tomorrow we have
Untitled.
1 to 2,
Okay.
right? So same meeting link, you can use it. You can save it this link. You can use it the same meeting link, and then see you tomorrow at 1 to 2. Okay?
I see. Thank you.
Okay, Aisha, take care of yourself. Bye bye.
Bye.
Bye.